Hi, my name is Omer Burakanbur, and for this work I performed multimodal sarcasm detection using early fusion and ensemble learning. The motivation behind this work was to be able to detect sarcasm using different sorts of video clips. The reason I was interested in sarcasm was that I thought it was very nuanced, and it's something that at times even human beings have trouble being able to differentiate. And the use of multimodal methods were especially interesting to me because I thought it would make the classification a lot easier, as it would provide more data in different forms, such as text, audio, and video in this case. Now, let's talk about the implementation. For this work, I used the mustard dataset, which contains different instances of sarcasm and non-sarcasm from different TV shows such as Friends and Big Bang Theory and etc. Uh, the data set contains three modalities of data. Text, which is what is being said. Audio, which is the tone and pitch and so forth of the sounds. And video, which is the visual features and aspects. So I utilized early fusion to combine these three different features and form one single data set using concatenation. And then I fed this data set into the two different models that I had built. So I have two different setups for this project. One setup is for speaker-dependent models, which is basically where the training data set and the test data set do not include the same speaker, as to not form biases on the tendencies of the speaker and such forth. For this model, I utilized two different SVMs, one with a linear kernel, one with an RBF kernel, and one model using a random forest classifier. I obtained results from these three different models, which each had around a 71% success rate, and I performed a voting ensemble on them. And the result that came out the majority of the time, whether it be sarcastic or non-sarcastic, was then outputted as the result. For the second model, it was built for a speaker independent setup, where the same speakers did not appear in the training data set and the testing data set. For this model, I utilized a SVM with a linear kernel, an SVM with an RBF kernel, and I performed a voting classifier on top of these again. But this time, the voting classifier was a soft classifier. So I took the probabilities of the results of the SVMs and I combined them to find the output with the highest probability, which gave me the prediction as to whether it was sarcasm or not. As you can see, I improved the results for the speaker dependent setup by around 3% in terms of accuracy, F-score, and recall. But I was not able to achieve this result for the speaker independent setup. However, I was able to achieve similar results on par with the previous work with my model. One thing I would like to note, however, is that my models seem to perform a lot better with modalities where text, audio, and visual were combined, whereas their work performed the best for text plus video for the speaker dependent setup and text plus audio for the speaker independent setup. I think that this is due to my voting classifiers and combining multiple models and getting a less biased model in results. The take-home message is that combining different modalities and features will give you better results compared to taking a single feature. Thank you for listening.